Hello everyone, welcome to the today's video. We are going to discuss about Kmeans. So Kmeans means it is an clustering algorithm and it is an unsupervised method. So till now we have been just seen some of our supervised methods. So this is an unsupervised methods. So this is one another example where you are going to just see with an unsupervised method. There is an another method called PCA, principal component analysis, which is used to decrease the feature sizes. So as we have been discussed earlier, PCA has been used to decrease the feature sizes of our images, and that is also an one of our unsupervised machine learning which have been used to have a dimension reduction. So this is dimension reduction, and this K means this is a clustering unsupervised method. So clustering method. So this is an unsupervised method. So unsupervised method means there will be no labels. Labels will be absent. So you will be having so when the label is not present, you cannot differentiate between two classes. So you need to cluster it based on the neighbors. So this is an this type of method where the things is going to happen based on the clustering. Okay, before going to this, diving to the today's session, the yesterday's we have been just seen about the SVM, that is a support vector machine. We have been just seen how to just have a sample linear and non-linear data to just differentiate between two classes. So if you're having a linear data, the thing is too much simple. We need to just have a hyperplane and you need to enhance the margin. So whichever the data features which are touching those margins are going to call it as a support vectors. So what we have been just seeing in the yesterday's session or in the last session. So here we have been just generated limit values for this. So in the same manner we have been just seen how to fit the data for linear and non-linear data. So if it is a linear data, we are just making a hyperplane with a margin and differentiating between two classes. So if it is non-linear, we are having two types. First one is increase the dimension from n to n plus 1, and next one is use the kernel method. So the dimension is like if it is a 2 dimension, we are going to enhance it to the 3 dimension. So this is a one, and the next one is like if you are going to have any sorts of kernel method, that is RBF. So it is going to find a what is this circumference of a class 2, and it is going to based on the distance between that circumference, it is going to make a classification between class 1 and class 2, a cone like structure. I guess you have been just remembered it. From the center of the cone you are just finding a O point, and from O point you are going to get a radius and you are going to find a circumference for it. So later on we have been just seen one of our example a real-time image, how to detect a face and how to provide a name for it based on the data set. So this is a face names and we have been just seen what are all the support vectors and which have been just generated. So this was all about previous sessions. So let's dive into the today's topic. So that is Kmeans. So introduction to the Kmeans. So sorry, it has been just gone here. Okay, in introduction we are going to have this one. It is an unsupervised method. What we have been just I have been just talking about on this unsupervised method. So this has been available in sorry, it is not. So it is not a scikit. It is been available in sklearn. So it is being just installed while you are going to install the scikit. So sklearn dot cluster dot Kmeans. So this is what where the Kmeans have been just situated in inbuilt fashion. So it is a clustering method. So either we can use this Kmeans or we can just have a building of a Kmeans from scratch. So after seeing the working, so we can just see how to build it. So first we can just implement by using sklearn.cluster.kmeans. So cluster learns from properties of a data by making a optimal division of group of points. See, consider if this was like some points. So based on the properties, so this radius is lesser. So it has been just made into one cluster. So this area is going to be high and it is going to make in a cluster 2. So like this, based on the properties of a data, so the optimal division is going to be made for a group of points. So it searches based on the number of clusters. So clusters will be just provided by the user. Preferably we will be going to have 3 or 4 clusters. So which have been assigned earlier by the user for a multi-dimensional data. Multi-dimensional data means it will be just as same as a clumsy data. So we will be having a working here. So like whenever the points have been scattered, it will be having some cluster center. So like whenever we are just providing a cluster, a random cluster value, so that cluster will be having some centers. So that center is an arithmetic mean. So for now sake, just understand that you will be providing a clusters for the user. For that cluster, we will be having some center. That center is arithmetic mean of all the points belonging to that cluster. So each point will be closer to its own cluster center than the other cluster centers. So consider this is a cluster center 1 and this is a cluster second 2. So for all these clusters, so the points will be nearer for this respective cluster compared to another cluster center. So this is what this line is going to just tell you here. So each points belonging to that respective cluster will be nearer to the its respective cluster heads or cluster centers. So the very good example is like our solar system. So our Earth and all the 8 planets will be revolving around the sun. So it will be belonging to the cluster head or a cluster center. So it is not going to another cluster. So this is like what this point is going to just give you information about. So before going to the working of algorithm, first we are going to create a data. So this is like what this thing we have been just discussed. So this is a broader view of a Kmeans. So we'll be having one center. Those center will be having 2 points. So let us create a data here. Okay, I am having the script here. Let me rename it to Kmeans. I'm going to reflect it. Okay, let me just create a. So these are the packages we are going to use here. Still more we are just using based on the requirement. So matplotlib to plot the results. So cborn to get a data set, and I'm going to create a data set. So this is just a data set. Let me just explain here. So here we are using sklearn. We are using the samples generator. Samples generator means points is going to be just generated and you are making a blobs of it. Blobs means some circles of data. Inside the circles you will be having points and it has been available in sklearn. You are using make blobs. Sample is 300 samples and we are having 4 centers for it. So cluster standard deviation is 0.64 and random state is equal to 0. So random state, if it is going to be 0, so for the next execution the points what generated will be same. So if you are giving 1, 2 or some of the things in random state, then for every execution the points will be of different values. Okay, we are just plotting this respective values here. X value, so you are making a blocks and it is going to be pushed to X and Y2. So here 0th column and the first column is going to be pushed. So we are going to just see the scattered data here. So we can just give a title for it saying that scattered data plot dot show. So this is like for generating a data set, generating the random data set. So we can just see this how it is going to just generate a data. So we are having 4 centers. In accordance with the 4 centers, the data will be just what is the splitting is going to happen, or like a flower pot. So the center will be there, 4 centers. From the 4 centers, data will be splitted like this. Okay, so this is a scattered data. So it is of single class. So it is of a single class, but we are having 4 cluster centers here. From that 4 cluster centers, data will be pushed like this. So this is same as like a earthquake scenario. Some center will be there and it will be booming like this. So this is just a scattered data or a user defined data which are being generated by having centers as 4. Okay, so this was like we have been just so it is here easy by and seeing with the eye, we can just make a 4 clusters like this. But for machine it becomes tougher. So this Kmeans automatically make a clusters using a sklearn. So here we are being just seen a respective, what is this here we have been just seen the respective classification or the 2 points what we have been just seen with. So that will be the base thing for any of our K-means classification. So these are all the 2 base points for a K-means classification. So center cluster, so it is arithmetic mean for all the points. So each points will be closer to its own cluster center. So here this is by seeing into our eyes, we can make a 4 clusters here like this. Based on the human tendencies, we can just make a 4 cluster here. So 2, 3 and 4 like this. So cluster 1, 2, 3, 4. So 4 clusters. But this is should be done from a machine. So in order to do that, we are going to make use of a sklearn Kmeans. So this is just a inbuilt version which have been already done. So we can just see the working of it, and let's start doing from the scratch after seeing the output from sklearn. So this is like a data generation, and here we are going for having a prediction. So prediction, what it actually does is, so wherever these points are coming into a picture, so consider the cluster Y. So this point, so it should be nearer to the cluster center, and that will be given with one of a color. It can be red. So next, coming to a cluster 2, so this points will be given with other colors, and some divisions is going to be happening. Divisions means it is going to provide some of the colors for that respective divisions. After yellow, you can just have the other colors here. So in the same manner for a cluster 3 as well. Okay, we can just see the coding part here, and this is an inbuilt version. We are going to predict the data. We are going to have a prediction, and as I told you earlier, the inbuilt version have been just available in cluster sklearn.cluster, and you are importing Kmeans, and you are just telling the cluster size as 4. So the user need to provide how much cluster you need to just do with. So you are going to fit it, and you are going to see the respective prediction of output. Okay, we need to plot it. So plot scatter. Okay, you can go for this. So prediction and scattering. So after scattering, you can go for show. So before this, you can plot title saying that Kmeans from scalar. Okay, we can just see the output here. So one thing is you need to keep in the mind that cluster heads will be there. Based on the cluster heads, we are going to make a arithmetic mean, and we are going to make a decisions. So here, so this is a Kmeans from sklearn. So this is from Kmeans sklearn. So let me just explain this by taking into a respective this. So it is not okay. We can just take a new slide. Kmeans. What we have saved this. What we have been saved. Forward. Sklearn Kmeans something like this. Okay. Psi Kmeans sklearn, it is already there. Okay. Kmeans. Okay, it has been saved. I don't know. Let it be Kmeans sklearn. Kmeans sklearn. So let me just maximize this. So I was been talking about the cluster centers here. We are having different cluster centers. From this, we are going to find a arithmetic mean. Whichever the points which are nearer to this cluster is going to make with a one division. So these points are going to be nearer for this cluster center. So based on this, some clustering divisions have been just made. So these are all the cluster centers. So these are all the cluster centers. So this is how the arithmetic mean is going to be just done, and based on the distance, so whichever the points nearer to the cluster center, they have been made to one of our classes. So we are going to generate a data separation. Manually we can differentiate the points by making 4 clusters, but Kmeans automatically detects. That is what we have been just seen. So plotting, we have been just seeing the output. So predicting the data separation into 4 clusters. Okay, let me just show you how this output is going to change if we are making only a clusters as 3. Okay, we can just see this. What will be the output? So now we are having the 4 cluster centers, but we are being just said that make a division for only a 3 cluster centers. So this is the same data but with a cluster center as only 3. So initially it was 4, now it was only a 3. So this is what the thing which is going to happen. So cluster only 3 we have been just given. So initially whenever the 4 has been just provided, so it has been divided into 4 clusters. Now it has been taken this 3 as a cluster centers, and based on this which are the points is coming near to it, so it is going to make a prediction, and it has been made a just what is this unsupervised classification. So this is a very beautiful thing we can just imagine here. So this is for cluster 3, so cluster 4, so 4 clusters, and it has been made a considerable differentiation. So here also it has been made a considerable difference by making a cluster into 3 centers. So based on the user's criteria, it is going to make a clusters. So plotting the results, so data points are separated with respect to the cluster heads. So this is what the respective thing. So then how it is going to make? So this is a easier concept. So K-means is very much easier. We need to find distance. We need to find a distance between the points and the cluster heads. Based on that, we need to just make a division. So that is simple. So this approach is going to be called as an iterative approach. So iteration means for one cluster head, first iteration is going to happen. For another, after finishing this first iteration, the cluster head's radius will be enhanced, and again mean will be going to happen. So this is like iterative approach. Iterative approaches is known as expectation maximization. So before going to this, just take this 3 steps which is going to happen in an Kmeans. First one is select the random center values based on the value of k. If k is equal to 4, you need to take 4 random centers. Second step is, so select centroid and perform so select each centroid or centers and perform the mean change from it. So considering this point, and this is a center head, so you need to find a mean of it. So repeat this till the minimum mean of center is going to happen. In other words, whenever you are going to find a distance, continue this till the new points is adding to the cluster. So till new points adding into the clusters. So these is a 3 major steps in an respective K-means, and for this we are going to write a iterative approach, and we are going to see this in the next slide. So first one is like select the random center value based on the value for k. If k is equal to 4, you need to select 4 random centers. So it is not having any rules here. Say take some 4 random centers. From that random centers, go on finding the distance point. So you'll be having some points. So you need to divide those points into clusters. So during that scenario, find a mean change. What is a mean change between between a cluster head and a point. If it is nearer, make it to this cluster. If it is far, push that point to the next cluster. So repeat this till the minimum mean of the center is going to happen. So what actually it means that, so till the addition of a newer points inside the respective cluster, you need to continue this iteration approaches. So this will be continuing till the new points will be adding to the clusters. So till the addition of a new points, this process will be go on happening. Every time the centroid value will be changed. So initially the random center value will be taken. After finishing one iteration, based on the observation of a splitting or a spreading of a data, it is going to change the centroid value or center value. So we can just see here. So here, working of a Kmeans, we are going to write this from a scratch. So Kmeans working is a very much simpler to understand. So here we are having a several contexts of expectation maximization. So this is like, it is an iterative approaches for finding the points as simple as humans are going to do it. So this method is going to be called it as expectation maximization. It is an iteration approach. So this is like for every iteration these points is going to be covered. So here EM actually means that it is going to perform these two tasks. E step, assign points for a nearest cluster center. So that is this second point is going to tell you. There is another step called M step, set of cluster center to the mean. So you are going to make a simple meaning of a data. So you are performing an operation called mean on the data for each cluster. So for this cluster you are performing a mean. So usually if the point is near to that cluster, the mean value will be lesser. So then the machine will understand that this point is having similar characteristics of a center, hence it is going to be clustered. So this is like two steps. So your E step is expectation step. So for every time the new data is going to be, or new points is going to be assigned to the nearest cluster center. So the next one is maximization step. So for each iteration, so the center value of a cluster will be expanded till it reaches the newer points. So this is a respective explanation. So it has been just illustrated in this respective figure. So this is the first step what I have been just told about in this point. Select the random center value based on the cluster. So here we are having 4 clusters. We have taken 4 center values. So first one is a E step. So it is going to add a newer point to the cluster. So this is going to expand in this fashion. So this is a first step. So this is a M step, maximization step. So for each maximization, for after having 3 steps, so the center value will be changed. So this was our earlier version. So it will be keep on changing for every iteration till the maximum mean of this cluster is going to be attained, or no any newer value is going to be added. So you can just see here. So here this center have been just shifted from here to here. So till the newer points are going to be just added to this cluster center, it is going to be separated from a cluster centers. So this is what the exact operation of a Kmeans. So this is a final clustering after maximizing its cluster distance, and it has been made some boundaries. Within that boundary it is going to make a cluster. So this is like, if you are giving any of a newer data, it will be clustering based on the respective distance between the cluster head and that new value. So we can just see this. Okay, we can see the output. So now we are going to construct a manual algorithm for Kmeans after seeing the algorithm. So this is a manual writing of a sentence. So this is what the respective from scratch what we are writing. So this was a inbuilt version. So now we are writing a user defined value for Kmeans. So here let me just explain this what actually it is. So we are just having one of a function called pairwise distance minimum value. So argument of minimum value. So pairwise distance means you are going to find a distance between two pairs. You are defining one of a function called find clusters. So for this you are having two inputs. One is input data points and the how many clusters it is. So and the next one is seeding value. So it has been just provided with the two. So why it has been two is like based on the literature survey of a papers. So this value is going to provide you a random states. So you are being just having some of a random states here. You are going to make some permutation with this random states to just have a random centers. So why this actually means this? So random center need to be just generated for this respective number. For this respective number, we are going to generate a random centers. For how many clusters, it is up to the user. You can send 1, 2, 3 or 5, anything. So whenever we are writing a function, it should be in generalized version. So that's why we have been written the program in general structure. You can push the clusters. So what we are having here, x of I. So x is input. So I is where exactly the state is being just random. So what is this? Cluster center have been just provided. That value will be accessed in x. So center have been placed inside the x and we are going to call it as the center values. First we are going to take a random numbers. So this random number should be seated inside the input values. So that's why we are taking x of I. So that is centers. So while the statement is true, while the sentence is true, you are going to assign a labels based on the closest center. How we are going to find the closest center? We are going to find a mean value and we are finding argument of a mean. See, like mean means we are just going to add and divided by it. So argument is going to do is if you are having minus also it will be just converted into plus. So what you are pushing input data and centers. So that is what this inbuilt is going to inbuilt K-means have been done. So this is a inner version or a scratch level we are just seeing pairwise distance. So what we are finding with the respective point of x with the first cluster center, second, third, like this it is going to happen. For the first center, it is going to find a labels. So labels means a random number. So here labels is not what we are going to see in a supervised one. That is different. This is different. So for giving a cluster name, cluster 1, cluster 2, cluster 3. So this is a labels. So new centers will be provided here. So np.array of this labels will be equal to I. You are going to make a mean of a center value. So whenever we are making a mean, it will be go on spreading like this. So after computing a distance, third point is make a new centers. So that is what which have been just done here. So after this, we are going to make this new centers have been equal to the respective older centers. If it is equal, we are making breaking of this respective function. If it has been not equal, then you are going to make that new centers as the previous center values. So you are returning centers and labels. Labels means name, that's all. Don't confuse with supervisor labels. So what we are just doing here, find clusters. We are pushing the input data X, the same data which we have been generated, and we are just telling you need to have 4 clusters and you are going to plot it. So after plotting, you can make this as a show. Okay, you can just give a title as user defined Kmeans. Okay, then you can just go for this. So this is a scattered data which we have been generated for 4 different centers. So this is for clustering 3 which have been just done using sklearn. So this is user defined Kmeans. So this is the same result what we have been obtained for cluster is equal to 4 using a inbuilt function. Okay, here I have been changed the cluster value to 3. You can just observe here. So you can just observe the same output will be generated from user defined values, scattered data. So this is Kmeans from sklearn cluster center, and this is a data. So this is the same data what this our user defined Kmeans have been just made by seeing the algorithm. So this is as simple as it we have been just made with a scratch. And then there is another important thing need to note down here. So in Kmeans, it is having its disadvantages. First disadvantages is it is an iteration process. Step by step it is going to happen, hence it is slower. If you are having larger data set, Kmeans is going to provide you a delay. This is a first disadvantage. Second disadvantage is like it is going to make a linear clustering. So whatever the data is like, it will be making in a linear fashion. So these are the 2 disadvantages. So we are having one real-time example here, predicting the digits. So digits means, so we'll be having 10 numbers to identify. See, like if you are going to write any of the numbers, so the basic version is the machine need to understand the number starting from 0, 1, 2, 3 to 9. So based on this combination, it can detect any number of digits which is being going to be provided for it. So this is a real-time thing, and this is like it is going to provide some accuracy. So this accuracy can be enhanced. So we can just see that in a tuning part. We are having a data set which is having 1797 samples. So for each samples, that is for each digit, we are going to take 64 features. So without having any labels, Kmeans is going to make a prediction based on the neighborhood values. So neighborhood means it will be dividing this image into respective rows and columns. So each row and column will be having 8 cross 8. Each image have been provided with 8 cross 8. So that is 64 pixels need to be analyzed for making a decision. So the image size is 8 cross 8. So the feature is 64. Why? Because 64 pixels have been available. Each pixel need to be identified and we need to make a prediction. So based on the neighborhood, it is going to make a sum of a decision. We can just see this. Okay, we can just go for an example. So we are loading. Okay, I can just explain this once. I am going to copy this. So after this, we are just having one real-time example. So after plotting, you can just go for plot.show. So let me explain this line by line. We are taking a digits, so which have been available in a data set of sklearn. We are loading a digits. So this is the name of a, what is this data set? We are loading into the variable called digits, and we are seeing the digits dot data dot shape. So you can print this value. What is the value of data dot shape? So how many features, sorry, how many samples you are having and what is the shape of it. So we are taking a Kmeans, it has been loaded from a sklearn. We are having a clusters of 10. Why this number 10 actually means that, so I was been discussing about this 0 to 9. So if you are counting this value 0 to 9 means the cluster, you need to make a difference of 10 clusters. So for each image, you will be having 10 clusters. So the output will be 10 clusters. Why? Because you need to have a prediction starting from 0 to 9. So if you are going to count this 0 to 9, the cluster, the number count is 10. So based on this number count, we are going to make the cluster size as 10. So this is same here. So this is like why this number have been just came into picture. So if you are understanding the concept, the programming is easier. So that's what I was being just telling. So random state, for every time this values will be same. So we are just making a fit of a function. So that is training part. So we are going to predict it. What we are sending data of our digits. So data will be available, that will be just going and sitting in a clusters. So we can just print this again. So print data values dot shape. So again we are having mode here, statistics. Why we need this mode? Like so first we are going to create a zeros cluster. So that is like a dummy variable. The size of a dummy variable of this label is same as that this cluster, that is data's dummy replicant. So consider this as a data. So you are going to create a replicant of it, but the elements are zeros. So here you are having range as 10. Why we need to execute 10 times means we are having 10 different clusters. So mask for each cluster 1, 2, 3, and you are going to find whether this are going to count whether the predicted value from the machine is equal to the targeted value. Based on this, we are going to find a accuracy. So accuracy is like what is the accuracy score which have been generated for this respective prediction. And in the same fashion, we have been generating a confusion matrix. So in the x-axis, you will be having true labels. In the y-axis, you will be having predicted labels. So by seeing this figure, you can just see the accuracy. And we are using a Kmeans for having a prediction of digits. So okay, this is scatter data. So this is earlier one, what we have been just seen in the earlier sessions. See here, first the samples are 1974, sorry 1797, and it is having a features of 64, that is 8x8 image. So it has been reduced to 10 clusters, 10 cross 64, and the accuracy they have been achieved in this Kmeans is 79%. So we can just see how to enhance this accuracy. Before that, this is a confusion matrix. So this is a confusion matrix for, so confusion matrix for Kmeans digits. That's it. So here you are having true labels. So here you are having predicted labels. So 0 has been correctly identified 177 times, but it has been wrongly identified as one sample as 4. So in this fashion, you can just see 1 have been identified as 1 itself, in many cases 55, but it has been wrongly identified as 24 times as a 2 also, based on the digits writing. So this is a confusion matrix and it is having accuracy. So now for a data set you are having 1794, it has been reduced to 10, that is 10 different classes. So for 10 different classes you are having 10 different 64 features. So here is what your image data set will be converting into a cluster size 10, and you are going to make a prediction. So now we can just go for what is this tuning value. So accuracy was 79.89%, and the confusion matrix, let me just take here. So the confusion matrix, where I have been saved this, whether it is in documents, no. Okay, let me save that again. Where I have been saved, oh, quick access, fine. So confusion matrix for digits without tuning, this one is. Okay, confusion matrix. So for digits. So here you can observe that where actually the major confusion have been just happened for a machine. So one is it has been failed to identify the number 1 as the 2, and it is having a confusion between differentiation between 1 and 8 here. So this is, you can just see the major changes. So here this is a major number, you can just observe here. So between 1 and 8 you are having a major confusion. So it is almost more than the correct deduction. It has been wrongly predicted as 8. So this confusion need to be tuned in a tuning part. So we are having some of our tuning methods, so which are being just called as an manifold learning. So we are going to just see what is this manifold learning actually means. That so in this there is a confusion between 1 and 8. So our job is to reduce this wrong decisions between 1 and 8. So this is what the tuning part is going to just do with. So we are going to make use of a manifold learning here using TSNE method. So TSNE actually stands for T distributed stochastic neighborhood embedding process. So this is a manifold method. So what it is going to do is like, so it is going to embed a respective values into a data set, or if you are having converting your 2D into 3D or higher planes. See, consider you are having a single page like this. So if you are going to fold this, it is going to enhance into a more than 1D format. So this is going to performed by an manifold learning. So it is a class of unsupervised estimators that seek to describe the data sets as low dimensional manifolds embedded in high dimensional space. So in low dimensional space, data will be just converted into a high dimensional space. So when you are going to think of a manifold, we are just suggesting imagining the sheets of images. So this is a two-dimensional object, so that it will be familiar in a dimensional object. So that is what we are going to just play whenever we are in the kits. We are going to make some boards and all. So the plane is paper itself. When we are enhancing, folding it, and we are going to extend it, that is going to be a manifold learning or converting into a higher planes. So we can just see the output here. So how this tuning part is going to happen? So tuning the algorithm. So the major wrong decision was at between 1 and 8. So now you are going to tune it. So we are going to see what is the score after this tuning value. So the same thing here, but we are using PSNE. So it is a one of a manifold technique. So that we have been just seen earlier. So what we are pushing components to. So you are having a 2 confusion here. So initialize it to a random, and you are going to make it as a in 1 and 8 we are going to have a confusion. We are going to make this fit transformation. Later again we are having same clusters, we are having the same procedure. Only the thing is you are going to project a data into higher dimensions. So if one have been projected into higher dimension, it can be viewed in another angle, and 8 is also going to be viewed in another angle, such that we are going to have a clear version for machine to make a decision, and rest are same. We are going to have a prediction for the same classes, and we are going to see the accuracy here, and it will be definitely more than 79%. So scattered data, Kmeans. Okay, this is user defined Kmeans. So here comes a confusion matrix for earlier values, that is confusion between 1 and 8. The earlier version was 79. So after this, it will take some time here to compute this composition. Why? Because you need to manifold the data into a higher dimensions. So that's the thing here. It takes some several seconds to convert your data into higher dimensions. So you can just see here P distributed stochastic neighbor embedding. So this is like viewing into an higher dimensional data. So it converts similarity between data points to joint probabilities, and it is going to minimize the respective errors. So you can just observe here, this is a very good accuracy for unsupervised machine learning I am just speaking with. It is achieved 93%. So this, what is this? The confusion between 1 and 8 have been rectified here. So this was a power of a usage of unsupervised machine learning with the usage of a manifold learning, that is PSNE. That's it for this today's session, guys. I have been just I guess you have got a worthful information. Let us meet you all in the next session. Thank you.